So let's begin the very last lecture of our semester, 5.6 Systems of Linear Inequalities. So pretty much a linear inequality is just like a linear equation, ax plus by, but instead of an equal sign, we have some inequality sign. This is less than or equals to. It could just be less than, it could be greater than, or it could be greater than equal to. And what we do is there's an infinite number of solutions to these systems, so we actually find out those solutions by graphing. And that's pretty much what we're going to do. I've not really decided how that's going to work on the final, but you will be given some opportunity to either hand sketch a graph or choose from several options, multiple choice. So let's look at this one. So we're asked to graph 3x minus 2y is less than or equal to 6. So what I like to do is I like my inequality signs to point to the left, because that's like the number line. As we go to the left on our number line, we're getting smaller and smaller. So what I'm going to do here is I'm going to exchange the positions of my 2y. You can just again treat these just like they are equations. The only thing you have to remember is that if you multiply or divide by a negative, then you have to flip the direction. And we're going to try to avoid flipping the direction. So now I'm going to divide everything divided by 2. So that's going to give me 3/2 x. Sorry, didn't mean to do that. Let me move this back down. Minus 3 is less than or equal to y. So if you want, at this point you can come over here and pretend like you've got a line, the equation of a line. So you would want to just replace this with y is equal, oh, there's an x right here. Y is equal to 3/2 x minus 3. So an obvious point on this line is our y-intercept, which is 0 and minus 3. So let's plot 0 and minus 3. Let's put that point there. And now you want to find another point. You can find another point any way you want, but I've been given that the slope is 3/2. So I can find another point by using my slope, my adder point. So this is my adder point right here, and it's going to give me another point. The adder point is I take the numerator of my slope, that's the y value, and my denominator is the x value, because it's rise over run. Rise is going up and down, so that corresponds to x. Run goes right to left. So 0 plus 2 is 2, and minus 3 plus 3 is 0. So I have another point at 2 and 0. That happens to be the x-intercept. So all you have to do is find 2 points, and that's it. Now what we want to do is we want to draw a line. And the line that we're going to draw is going to be solid if our inequality has an equals. That would be less than or equal to, or greater than or equal to. It will be dotted if it's less than or greater than. So what I'm going to do right here is I'm going to draw my line through these 2 points. I started off right and then I messed up. Not a very good line, right? Let's just do it all over. So here is there, and here is that part. So here it says we have to actually decide So notice that this is the line right here. Let's actually label it. This is the equation. This line is the equation. Y is equal to 3/2 x minus 3. That's what that line is. So the points, this line that I just drew divides the Cartesian plane into two halves. So one of those halves are going to contain the solutions, and the other half won't contain any solutions. And since our line is solid, points on the line itself will be in our solution set. So it says y is greater than that. So that means if I look at my line, greater means up above. So what I do is I shade in that area. I don't know if this will work. Let's see. Yeah, so that's the area of the graph that I would shade in. Another way to do that is to just use a test point. Use a test point like 0 and 5. That would be right up here on the graph, somewhere right around here. So, and then I would plug it into the original equation. 3 times 0 minus 2 times 5. And is that going to be less than 6? Well, yeah, minus 10 is less than 6. So that also tells you where the shaded portion of the graph will go. So that's one. So I'm going to start out with a new canvas by opening. I've got all of this set up. What I had to do for that to work was there's invisible lines around here, and you don't see them, but that's what allows the fill feature to work. Ah, you saw it right there, didn't you? Oh, that's interesting. Maybe I can lock one of these. Yeah, I think that worked. I'm going to move it over here to the side. So let's look at another. Okay, sorry about that. I just turned off everything that might distract me. So our next problem is x plus 4y is less than 4. So the thing to note here is the less than. That's going to indicate a different type of line. But again, we solve for y. I'm going to leave y where it is and move the x over. And then divide both sides by 4. So this gives me y is less than minus 1/4 x. That's my slope, plus 1. So we have 1 point. As remember, we can treat this just like it were an equation, because that's what we're going to be doing, is graphing the equation of this line. So one obvious point is the y-intercept at 0 and 1. So let's go ahead and plot that at 0 and 1. Now we need to find another point, and what I'm going to do is use the adder point taken from my slope. Now here's a minus 1 over 4, so I can attach the minus to the 1 or the minus to the 4. I'm going to put the 4 here and attach the minus to the 1, and I'm going to add. So 0 plus 4 is 4, and minus 1 plus 1 is 0. And that gives me another point, which actually happens to be the x-intercept. Now I'm going to go ahead and I'm going to draw a line through those 2 points. Now I'm not done with this line yet, because this line needs to be a dotted line. So the line y is equal to minus 1/4 x plus 1. That's this line right here. It needs to be dotted. Why dotted? Because our inequality right here doesn't have an equal sign. So for me, what I'm going to do is I'm just going to use my eraser and make it dotted that way. And I shouldn't have really done that because I'm actually going to undo it. So just remember it has to be dotted. So the question is, where do we plot? The area that we shade in is the area that is the set where all of the solutions are. So here, y is less than this line. So we're going to shade in the bottom part of that line. So it's this area down here where the solutions are. And now that I've done the shading, I'm good to go. I'm going to make the line dotted, and everything is complete. So just drawing little dots here. I know this computer program isn't the best, but I'm making do with it pretty good, I think. And this is how I'm actually dotting the line. Of course, if you're drawing these, it needed to be a solid line, because as a solid line, it will detect the region to shade in. And the important part you realize is this right here. This is the region, or if you want to call it the area, of the Cartesian plane with the solutions. So let's just explain this. This is a point down here, x and y. Well, x is going to be, what, around 7, and y might be minus 6. And that point is contained in the infinite number of points that make this inequality true. So let's open up. Same thing again. And lock that layer. See if it works. I believe it did. So here we have just some hints on how to graph. This is taken directly from the textbook. So if the inequality can be solved for y, then y is less than the equation of the line, means you choose the region below the line. If y is greater than the equation of the line, then you choose the region above the line. If the inequality can't be solved for y, then just choose a test point that's not on any of the boundaries, and plug that test point into the original inequality. And if it turns out to be a true equality, that's the side of the line that works. If it turns out to be a false inequality, choose the other side. So now let's move on to systems of inequalities. So a system of inequalities is going to be very, very similar to a system of linear equations, but there's no matrix methods to solve these. What we do is we find the region that solves one of the equations, then we find another region that solves the other, and we take the intersection of those regions. So let's do this carefully. I don't know that I'll be able to use my shade-in features here, but for right now, let's just look at the two equations given to us. The first equation, or equation 1, to unlock this, equation 1 is given by x x is greater than 6 minus 2y. So again, I like to write things where we have the inequality pointing this way. So 6 minus 2y is less than x. But at the same time, I want my coefficient on my y to be positive. So that means I'm going to move the x over and my 2y up. And now I'm going to solve for y. Everything is going to get divided by 2. So that gives me 3 minus 1/2 x is less than y. So what we want to do is plot the line y is equal to minus 1/2 x plus 3. And immediately, again, we know 1 point, 0 and 3 is on that line. Let's find another point. Let's find the adder point. So I'm going to attach the negative to my numerator. So 2 and minus 1. And when I add those points together, I get my other point, which is 2 and 2. So let's plot those. 0 and 3 is my y-intercept. And then 2 and 2 is my other point. So what type of inequality do we have? It's less than or equal to. So that's going to mean that we want to draw a dotted line. And I'm not going to draw a dotted line at first. I'll dot it at the very end. So let's just plot the line y is equal to minus 1/2 x plus 3. And I have 2 points, so I can do that. Don't want to do it with that color, though. Let's use red, maybe. So that's more or less the line. Y is equal to minus 1/2 x plus 3, which we will want to dot at some point. We have to make it dotted before all of this is over. If you're doing it with pencil and piece of paper, it's a good idea just to do it right now. But notice our equation says that y is greater than that. So that means the region of the plane that's going to be included is going to be this region up here. I'm just going to put little bitty lines up here for right now, and I'll try to shade it later on. The reason I'm not shading it right now is because we have a second equation. Our second equation was x squared is less than 2y. So again, as always, we're going to solve for y. So we're going to divide both sides. X squared divided by 2 is less than y. Go ahead and do f of x is equal to x squared over 2. So that's going to be what we're going to plot, and we're going to use a table of values to do that to get a few points. And again, that line 2 is going to be dotted, but at the very beginning I'm going to make them solid, so the regions are going to hold. So we're going to have x and then x squared over 2. So I'm going to do 0. That's 0. I'm going to use even values of x. 2. 2 squared divided by 2 is 4 divided by 2. That's 2. And if x is minus 2, 2 squared is still the same as 2 squared is 4, divided by 2 is 2. So let's do 4. 4 squared is 16, divided by 2 is 8. And minus 4 squared is 16 divided by 2, and that gives us 8. We could do one more, maybe. Will it fit? I don't know that we'll have room to do it, but let's go ahead and do 6. 6 squared is 36, divided by 2 is 18, and minus 6, 18. I don't think I'll have room to get these last 2 points, so let's plot these points on our graph. So this is going to be a parabola. You can kind of already guess where it's going to be. I'm going to have 1 point. My next set of points is 2 and 2 and minus 2 and 2. My next set of points are 4. Right, there's 4 and 8 is right there. And then minus 4 and 8. So we're going to try to draw, I'm going to try to draw, it's going to be an abject failure. This is my parabola. So for this second part, again, let's go over here and let's see what it says. Y is greater than that parabola. So we have y greater than that. So the values of y that's going to work are going to be the values included in here. And indeed, it has to be above this line and in here. So if I'm lucky, when I do my fill-in right there, that's the area that works. And of course, I'm not complete because I need to make these dotted. All of these should be dotted. By making these dotted lines rather than solid lines, both of them, it tells you that on the boundary of the line itself are not included in the solution set. So a point right there on the boundary, for example, the point 4 and 8, which is on the boundary of the parabola, is not a solution. Why? Because it's on the boundary. I think we have one more to do, and that's it. Again, let me open up a new version. And see if I can move it over. Yeah, it seems to be working fine. So in this case, we have 3. I'm just going to go ahead and write this down. I have it copied over here so I can see it. I'm going to write our 3 equations here. So one is the absolute value of x is less than or equal to 3. So that's going to indicate a solid line. The next is y is less than or equal to 0. And the last one is y is greater than or equal to the absolute value of x plus 1. Sorry. Absolute value of x plus 1. So let's start with our first equation. If you remember when we're talking about just real numbers, if the absolute value is less than or equal to 3, that immediately means that minus 3, x is greater than minus 3, greater than or equal to minus 3, less than or equal to 3. So that's just talking about on the real line. But here, now we just change these into two-dimensional objects. So that means that the equations minus 3 is equal to x, and 3 is equal to x are our boundaries. So let's write those in. So right here is minus 1, minus 2, minus 3. 1, 2, 3. And we can draw lines through it. In this case, I don't really need anything. I can just use that as my boundary. Don't like it. There's one. Here is another. So that means x is between those two. So we'll just come back later on. So the next one, so I've taken care of that one. So in other words, this region in here, in between, is what satisfies the first one. And remember, I have 3 sets, and I'm taking the intersection of all of the sets. So once I find this set, which should look like, it's not wanting to do it now. It's not doing it. That's okay. Maybe because it's locked. No, they're both unlocked. Anyway, we'll just do it this way. It's all of this stuff in here. So that's one set. That's our shading right there. How's that? Now, y is less than or equal to 0. Well, you just start out plotting the line. Y is equal to 0. And that's the same thing as just the x-axis. It's a horizontal line. So that means all of the points below the x-axis. So in taking the intersection, the only part we have right now where I have the blue streaks and the yellow streaks is this part right here. So now let's look, y is greater than the absolute value of x plus 1. Remember, the absolute value is a v-shaped. So if y is equal to the absolute value of x plus 1, then I just write the equation. It's just the equation, the graph rather, of y is equal to the absolute value of x, excuse me, lifted up by 1 unit. So it's going to look like this. And all of the things that satisfy it are up here. So if you can see, we're taking the intersection of all of our colored areas. But we don't have any part of the graph that has both blue and red and yellow. That's the intersection of all of them. So the answer is no region works, or the empty, it's the set that satisfies it is the empty set. And if you prefer just the words no solution, I'm cool with that too. And that's it. That's all we're going to do. That's the very last lecture of this course. And the very last homework is already put up, and pretty much it's basic, simple stuff like this. If you have questions, just let me know.